Morning guys. Today what I'm going to do for you is carry out the double replacements reaction lab. In this lab, what you're going to do is watch me perform 15 double replacement reactions. Together, we're going to make observations and identify what was formed. After the video, we are going to write in the products and maybe even balance these equations. In addition to this lab being fun, this lab is meant for us to practice in order to help us with our understanding of why double replacement reactions take place, and practice in terms of writing formulas for ionic compounds, which are the products for all of these processes. We're going to carry out each of these reactions in a small test tube. The substances are in the label droppers, which you can see on the table in front of us. I'm organized. I laid them all out. I alphabetized them so that I can easily find them. And then when I go through each reactions, I'm going to identify the substances and I'm going to add 2 to 3 drops of each. I'm going to be careful, not going to touch anything to anything else because I don't want any reactions to occur or contaminations to occur that I didn't intend to happen. All right, now in this activity, all of these reactions are going to take place. We'll write down our general observation and we'll identify what is formed. Generally, if we observe that the solution became cloudy, changed color, then we can say a solid formed. If we couldn't identify any changes, then a liquid most likely formed. I'm going to also use some litmus paper to help you guys to see that this reaction takes place. If we see bubbles, that means a gas forms. At this point, we're ready to begin. Alrighty guys, I'm going to go ahead and carry out each of these reactions in this small test tube that you see suspended in front of you. In the first reaction, I'm going to be mixing potassium sulfate, K2SO4. Alright, so if I hold it here and you look in, it's clear and it's colorless. So I'll go ahead and I'll add some drops to the bottom. There you go. And again, you can see there in the bottom that it is clear and it is colorless. To it, I'm going to be adding barium nitrate, BaNO3. And again, if I bring that in front of the camera, another clear, colorless solution. Let's see what happens. Oh. Immediately, the solution changes color. It changes color to cloudy and white. Remember that if there's a color change, or the solution becomes cloudy, or both, like in this situation, what we have is a solid that has formed. Next, reaction number 2, we are going to be mixing cobalt 2 sulfate. If I have it here in front of the camera, you can see that it is pink and transparent. Pink and clear. I'll add some drops. You can visualize that in the test tube. To it, I'm going to be adding potassium hydroxide, KOH. If I bring that in front of here, you can see that it is clear and or colorless and transparent. When I add it, my solution becomes cloudy. Remember, cloudy and or color change indicates that a solid has formed. In my next reaction, reaction number 3, I am going to be mixing sodium hydroxide and iron 3 nitrate. I'm looking for sodium hydroxide. I know I have it. Here it is. Okay. If I bring it into the screen, you can see in the bottom of the bulb, this is also colorless and transparent. drops here, add some drops, there we go. And to that, I am going to be adding iron 3 nitrate. When I bring iron 3 nitrate, you can also see that this solution is transparent, but it has a yellow-orange color. When they mix, I get the formation of a deep orange color. That is an indication that a solid has formed. That's my precipitate. For reaction number 4, I'm going to be mixing sodium chloride and lead 2 nitrate. Sodium chloride there we go. So if you can't already tell, we can look at the bottom of the bulb here, and you can see that it is also colorless and transparent, like everything else we're using for the most part. And to that, I'm going to be adding lead 2 nitrate. Before we add, again, if you look at the bulb, colorless and transparent. I don't understand why a reaction does not happen here. This actually happened before. There is supposed to be a reaction. There is supposed to be a formation of a solid between lead and chlorine, and for whatever reason, you can't see it, but it's supposed to happen. We are going to write down that a solid formed. I don't understand why it doesn't work. I really thought that lead and chlorine do you have your table of solubilities? Will you check that? In our next reaction, this is reaction 5, we're going to add iron 3 chloride ions. Okay, so I'm going to use a different looking dropper. I'll bring it up to the screen for you. But you can see this is transparent, but it has a yellow-orange color.
It should.
Yep, that's what I thought. I don't understand why it's not working. And to it, I am going to add sodium phosphate, Na3PO4. And when I bring this into the screen, again, you can see that it is clear and it is transparent, or colorless and transparent. When I add this, what you should see is that it is becoming cloudy. It might be difficult, but there is a white solid in there. We're going to write down that the solution became cloudy and that a white solid formed. In our next reaction, okay, we have lead nitrate, which we've already observed before as being transparent and colorless. And then we have potassium iodide. Okay. Here's potassium iodide. Maybe you can see that it has a very pale yellow color to it. When I add it, look at that. Canary yellow precipitate. So the solution turns yellow. Next, we have a reaction between cobalt 2 sulfate, which we have observed before as a transparent pink liquid, and sodium phosphate, which we have observed before as a transparent and clear liquid. when I add that, the solution changes color. It goes from pink to bluish purple. We can write that down. Bluish purple. Okay. Again, a color change is an indicator that a solid has formed here. That solid is blue in color. Our next reaction is hydrochloric acid and sodium hydroxide. And for this reaction, I'm going to carry it out both in the test tube and using pH paper. So hydrochloric acid is an acid, obviously. And for those of you who don't know, sodium hydroxide is a base. And acids and bases have very distinct pHs. So I just need a moment to arrange my pH papers here. Let's see if this works. Okay. Here they are. I'm going to tape them up here. Here we go. You can see them. So my acid, hydrochloric acid, it's here. It's transparent. It's clear. I'm going to add it to my test tube. Okay. And then I'm going to add a drop to my pH paper. All right. And what we can see is that it turns my pH paper pink or red. Sodium hydroxide. Sodium hydroxide is also clear and transparent. I'm going to add some drops here. 1, 2. I'm trying to add equal amounts of each. I don't know if I'm doing that or not. I'll also add a drop to my pH paper. Sodium hydroxide turns my paper blue. Now, if you didn't notice, when I added the sodium hydroxide to the hydrochloric acid, there was no visible reaction. However, when these two substances mix, we make water. And water is neutral. Water also drives a double replacement reaction to happen. I don't know what, so I did not add an equal amount. Bummer. Which is why that is still pink. What I was hoping to do was add exactly the same amount of each so that when it mixed, it became neutral and you could see a different color on the pH paper. Unfortunately, I didn't add an equal amount of each. I want to see something here. Okay. Note that when I added the acid on top of the base, you can see that the color has changed. It's because the acid and the base are reacting with each other to form something that is neutral. And eventually, when that reaction happens, the paper will change color, and it'll be more of its original color, maybe a little green, than it was before. So here, if you look, in between 6 and 8 would be the color that we're looking for a complete reaction of an acid with a base. If there's some left over, like what happened in the test tube, the paper would either be acidic, like in this case because there's too much acid, or it could be basic if I added too much base. Okay. But again, there was no visible reaction. There's nothing you can write for your observation in that part other than the acid turned the pH paper pink and the base, NaOH, turned the pH paper blue. On our next reaction, we are mixing silver nitrate. Again, I'm using a different kind of dropper here. Might actually be hard to see because this dropper is dirty. All right, but I'll hold it up anyway. Okay, so this solution is also colorless and transparent. All right, I added it to my test tube, and to it I'm going to be adding ammonium chloride. Here's my ammonium chloride solution, colorless and transparent. When the two mix, the solution turns cloudy and white. Again, the change in color and the cloudiness indicate that a solid was formed. In my next reaction, I'm going to mix hydrochloric acid and sodium bicarbonate. Where are you? Here this is. Hold on for one moment. If you look, my sodium bicarbonate is clear and transparent. Okay. And as we've already observed, my acid is also clear and transparent. Now I was going to try to maybe zoom in a little more here, but if I go too much then you won't see anything. When I add the two, I don't get a color change, but I do get lots of bubbles. Okay? The formation of bubbles tells me that a chemical reaction has taken place. Next, I'm adding sodium hydroxide and copper 2 sulfate. Sodium hydroxide, as we have observed before, transparent and colorless. Copper 2 sulfate is a light blue transparent solution. When I add the two, I get the formation of a blue gel-like substance. So the mixture changes color, and that is the indication that a solid has formed. Okay, a few more to go. In reaction 12, we have silver nitrate again. We have observed it as a clear or colorless and transparent solution. You can see that when I add it to the test tube. And to it, I'm going to mix table salt, NaCl. NaCl, when dissolved in water, is also colorless and transparent. When I mix the two, the mixture changes color, cloudy and white. Again, signs that a solid forms. So you can start to see that lots of double replacement reactions involve the formation of a solid. In reaction 13, I'm mixing potassium hydroxide, KOH. Okay, transparent, colorless. And I am mixing it with copper 2 acetate. This solution is a much darker blue. but it is still transparent. Yes, transparent. When I mix the two, solution changes color, becomes cloudy. The cloudiness indicates that a solid has formed. Next, silver nitrate and sodium phosphate. As we've already observed, silver nitrate is colorless and transparent, and we'll see it again when it's in the test tube. We've also already observed sodium phosphate. Here it is, colorless and transparent. When mixed, solution changes color, becomes opaque, so it's not even cloudy, it's totally opaque, yellow. The color change and the opaqueness indicate that a solid was formed. Last but not least, barium nitrate and copper 2 sulfate. Barium nitrate, transparent and colorless. Okay. Copper 2 sulfate, we've already observed, transparent, pale blue. We mix the two. Solution changes color, becomes white and cloudy. Both signs that a solid has formed. Now what we'll do is come back as a whole group. We'll write products, identify what formed, and balance the equations if we have time.